Okay, welcome to part 5 of this lecture. The good news for you guys is this is most of the lecture for this unit. There's a couple other things we need to talk about, but this pretty much covers it all. So right now we were just talking about physical changes. So we've been talking about chemical properties, physical properties, and now we're going to talk about physical changes and chemical changes. We were just talking about physical changes, that is ones that are like melting to freezing, that kind of things. They can often be undone. So that kind of thing. A chemical change, we were right about ready to start chemical changes. Chemical change is a change that occurs when one or more substances are changed into entirely new substances with different properties. They cannot change back under normal conditions, although there are some, just be aware that, because I don't want you to be confused if you ever take other chemistry classes, there are some chemical reactions that can go backwards and forwards. But for now, just be aware that most of the time, you cannot, once you, like, for example, once you bake a cake, you cannot go back to raw batter, correct? So that's a chemical change. So like baking a cake is like our huge everyday example. Okay, baking a cake, you cannot go back to raw batter, right? Okay, you can't get there, right? Can't get to raw batter. Okay. All baking, all cooking is chemistry, and just remember that you cannot get back to the raw products. Um, Common examples: reactivity, oxidation, for example, rust on a bicycle, pH, acid base, like your effervescent tablets, that's a good one. Flammability, burnt wood. Once the wood is burnt, you can't get back to the wood, okay? Combustibility, fireworks. If you've ever set off fireworks by yourself, you can plainly see that you ain't getting back to the firework the way it was before. It's done its thing. It's over. It's used. So you know this in your everyday life. The chemical changes are generally cannot be undone. In chemistry, we generally look for signs of a chemical change because it's really hard to tell if they've happened. And some of these you know intrinsically, or you may have been taught before, but we're going to review them anyway because we're going to do a lab on this later. We're going to look at chemical changes. The only way to know that there's been a chemical change is to observe if there's been a new substance formed. But since we can't look down at the atomic level, we can't zoom in at the atomic level very well, especially as the junior scientists that we are. It's really hard to tell. So there's some common things that we look for, and you're going to need to know these 5 signs of a chemical change. Okay, so we have 5 signs. There's 5 things to look for, and number 1, odor. Okay, odor. Production. Most um, odor is often a sign of a chemical change. Okay, this would be an odor far different from what it should smell like. So when you peel an orange, you're just smelling the orange oils going into the air. Okay, and it smells like an orange, right? So the orange smells like an orange. That matches. But if you see, if you find a dead body of any kind, like you find a dead rat in your um, closet or a dead frog somewhere or whatever, then that smells like a very, very specific smell, right? You know, that doesn't smell like it does when the thing was alive. That is an indication of a chemical change. Something's going on when that thing doesn't smell the way it normally does. It doesn't smell the way it did before. That's a sign of a chemical change. The second sign of a chemical change is a change in temperature. Okay, so we have if you can think about it, so there's 2 changes in temperatures we can have. We can have temperature changes that go up, and we have temperature changes go down. When you feel an up temperature change, that's called an exothermic reaction. Okay, so that's another vocab word. So that's why this quiz on Fridays we heavily vocab. an exothermic reaction. And in order for the temperature change to go up, energy has to be released. So energy has to go from the test tube. Whoopsie. Okay. Where are we? Okay. So in order to get, so this is my lame test tube. Okay, we can do, even Mrs. Maynard can do better than that. Okay, so let's try this again. It's really hard to draw. We left-handed sometimes. Okay, so in order for there to be an exothermic, the energy has to go out. Okay, and that's what you're seeing when you get an exothermic reaction, and that makes sense with the fire. The energy is coming out. Okay, we saw this most famously in our class with the elephant toothpaste. Okay. Now we can also have a energy is absorbed, and that's a decrease in temperature. Well, you're like, well, if the energy is absorbed, why is it a decrease in temperature? Because it is taking the heat from the surroundings and it is absorbing it. And then this feels cold. Ooh, cold. Okay. Our most famous examples, if you take those instant 1 second, I'm at home and I have 2 dogs who are trying to fight for dominance right now. Okay, the fight ended on its own. Not a real fight. Just a scuffle. All right, so the most common example is the ice pack. You break open that ice pack, you break the little tiny pieces of plastic that are inside that are keeping the chemicals from each other. When those 2 chemicals react, they form a reaction where they're absorbing all the heat from the environment, and then, ooh, cold. Okay, so that's what we got there. So then we have the third sign of a chemical change in color. So you've done this already. You've seen our color change challenge where we look for very specific changes in color. Okay. Leaves changing, not that we deal with that very much here in Arizona. Dyed hair, both of those are chemical processes. Okay, and once the leaves change color, they don't really go back. You have to get new leaves, remember? And the fourth sign is bubbles. Okay, so we saw bubbles again in elephant toothpaste. Okay, here it might be denture cleaner. Or I don't even know if anybody still uses Alka-Seltzer anymore. So those create bubbles. And then I don't even know what that is, but I think that's supposed to be some other reaction that changes bubbles. Now, when you think about it, this bubble process, it cannot be because something is boiling or changing, okay? It is a chemical change. It is not produced because you've been heating it up and you are now boiling that substance. Remember, boiling is a what kind of change? Okay? Think to yourself. Boiling is a physical change. This is not just boiling. Okay? And then very quickly, because we're running out of time again, the fifth sign of a chemical change is the formation of a precipitate. That word is called precipitate. And that's when 2 liquids are combined and a solid is produced. This is one of my favorite things, and maybe we'll do some demos, but ooh, solids. Ooh. Okay, so that's the 5th sign. Okay, make sure that you follow